Hello and welcome to this lesson on initial value problems. So, antiderivatives, indefinite integrals, and initial value problems. In a previous lesson, we went over antiderivatives. Antiderivatives are also called indefinite integrals. In this lesson, we are going to use indefinite integrals to solve initial value problems. When we saw antiderivatives, indefinite integrals, we had to put a plus c at the end of all the problems. The reason is that all antiderivatives are off by a constant. In this lesson, we will be given a bit more information, and with that information, we'll be able to find the constant. So, example 1. Find the function that has the given derivative and initial conditions. So f prime of x, the derivative of f, is equal to 12x. And f of 2 is equal to 7. So on our function, when x is equal to 2, the y value is equal to 7. So let's take a look at the solution. We are given the derivative of a function, f prime of x is equal to 12x. To find the function, we have to take the indefinite integral, the antiderivative of 12x. So f of x is equal to the antiderivative of 12x dx, which gives f of x is equal to 12 times 1/2 x squared plus a constant. So 12 times 1/2, that gives me f of x is equal to 6x squared plus a constant. Now we were given that f of 2 is equal to 7. So plugging in 2 for x and 7 for y, that's going to give us 7 is equal to 6 times 2 squared plus a constant. Well, 2 times 2 is 4, and 4 times 6 gives us a 24. So 7 is equal to 24 plus our constant, so our constant has to be negative 17. Updating our function, this gives us f of x is equal to 6x squared minus 17. Let's take a look at another example. So example 2, find the function that has the given derivative and initial conditions. So the second derivative of our function is 12 times x. And the first derivative, f prime of 2, is equal to 7. So when 2 is plugged into the first derivative, I get an output of 7. And f of 0 is equal to 9. So we are given the second derivative of a function. The second derivative is equal to 12x. To find the first derivative of the function, we have to take the indefinite integral of the second derivative. So f prime of x is going to be the antiderivative of 12x dx. So that's going to give us f prime of x is equal to 12 times 1/2 x squared plus a constant, which gives us f prime of x, the derivative, is equal to 6x squared plus a constant. Now we were given that f prime of 2 is equal to 7. So I'm going to plug 2 into x and 7 into m. So I chose m because if you remember, the first derivative represents the slope. So m is 7 is equal to 6 times 2 squared plus a constant. 2 times 2 is 4. 4 times 6 is 24. Subtract my 24 over, and that tells us this constant is equal to negative 17. So updating our first derivative, that gives me f prime of x is equal to 6x squared minus 17. Now that we have the first derivative of the function, we will take the indefinite integral, the antiderivative again, to find the function. So f of x is going to be the antiderivative of 6x squared minus 17 dx. So this is going to give us f of x is equal to 6 times 1/3 x cubed minus 17x plus a constant, which gives me 2x cubed minus 17x plus a constant. Now we were given that f of 0 is equal to 9. So if I plug in 0 for x, the y value will be 9. So this is going to give us 9 is equal to 2 times 0 cubed minus 17 times 0 plus c, which gives me c is equal to 9. So updating our function, this gives us f of x is equal to 2x cubed plus minus 17x plus 9. Alright, let's take a look at a third example. So find the function for the height h of t of an object where the acceleration is negative 32 feet per second squared. The velocity when t is equal to 0 is going to be v0, and the height when t is equal to 0 is h0. Now we are given the acceleration. The acceleration is our second derivative, so that is a negative 32. Taking the antiderivative of acceleration gives us velocity. So v of t is equal to the antiderivative of negative 32 dt, which gives us v of t, our velocity equation, is equal to negative 32t plus some constant. Well, this is our velocity equation. When t is equal to 0, v of t calculates to v0. So that gives us v0, replacing v of t with v0, is equal to negative 32 times 0 plus c. So that tells me that constant has to be v0. Updating our velocity equation, that gives us v of t is equal to negative 32t plus v0. Alright, the height is the antiderivative of the velocity. So h of t is going to be the antiderivative of negative 32t plus v0 dt. So h of t, that gives me negative 32 times 1/2 t squared plus v0 times t plus some constant, which simplifies to h of t is equal to negative 16t squared plus v0t plus a constant. Now we were given, this is our height equation, and we were given that when t is equal to 0, h of t is equal to h0. So if I replace h of t with h0 and I plug 0 into my t's, I get negative 16 times 0 squared plus v0 times 0 plus c, which gives me c equal to h0. So updating our formula, this gives me an equation for height. So height is equal to negative 16t squared plus v0 times t plus h0. Alright, so the result of this example 3 basically says if you know the acceleration, then you can find the equations for velocity and position, assuming that you have at least one velocity and one position. So thank you for watching this lesson, and I will see you next time.